So in this question, the problem is indicating that we have an alcohol. So we know we have an OH somewhere on our structure. It's also indicating to us that on the carbon NMR, we have a peak at 69-ish, 32, 22, etc., which means that as we go more downfield, we're getting closer to that alcohol. The thing at 10 ppm, I'm going to label this A, B, C, D so we can follow along. The peak at A has to be furthest from the alcohol. The peak at D has to be the thing closest. So we know that there's a carbon, you have your OH, and there's a carbon attached. We don't know what kind of carbon it is yet, but it's attached. It says on the dep 90 that dep 90 show CHs. So that means that D has to be a CH. That means there's two other things attached. We don't quite know what they are yet. We already know that on 135 we see CHs versus CH3s because the we know that the one at 69 is already a CH. We already have made that assumption that it's a CH because of the dep 90. We know that 22 and 10 do not show up on dep 90, so they must be CH3s if they're positive on the dep 135. And because 32 is negative, it's a CH2. So we know that C is a CH2. We know that A and B are CH3s, so they must be at the ends of things. So we know that, for instance, the CH2 has to have two things attached, but it's close to the alcohol. So I'm going to assume that I have a CH2 near to that alcohol. And that carbon D, and so that I'm going to label C, D still needs something on it. And I see that I have a CH3 that is also a little bit close to the alcohol, but not directly attached to it. And we're going to talk about why these numbers are actually so different in a little bit. And then I have one more CH3 that's even further away. I'm going to say that's A. Okay. Now, the question you should ask yourself is, why is C much more downfield than B? And remember, it's not just the nearness to alcohols, but the de-shielding. So we get de-shielding from alkyl groups as well, because remember, alkyl groups can undergo hyperconjugation, which is the pulling of electron density. So we get de-shielding from alkyl groups as well. And that's because of hyperconjugation. Hyperconjugation, again, just is the sharing electron density. So by having two sets of alkyl groups on either side of C, it makes it a little bit more downfield than, let's say, B, which only has one alkyl group attached.